Welcome to Blockchain 101. My name is Neftali Cruz, and I lead the blockchain capability here in Advanced Technology Centers in the Philippines for Accenture. We call it ATCP. How is blockchain that powers Bitcoin relevant to whatever is happening right now in our communities? Of course, with the COVID-19, with all of these pandemic discussions, why is blockchain relevant? Why is Accenture talking about blockchain to its peers and community? So I would say that it has come to a major attention in the communities and the governments lately because of the blockchain technology. In fact, many countries nowadays have developed their own applications and has been developing applications using blockchain. In other countries, they actually developed the application on contact tracing using blockchain. Some have used digital identity to make sure that they capture the information of their patients, those in quarantine. And most importantly, the supply chain nowadays, so the ones that develops vaccines, they use blockchain to do track and tracing of their shipping, development, and manufacturing. So it's very relevant nowadays. In fact, in our situation in the Philippines right now, if you probably all know about the Bayanihan program which the government has, and probably you might be asking yourselves, there's a lot of communities, lots of donations being asked, and have you ever asked yourself, what if I can track and trace my donation from the platform that I donated to the LGUs, down to the actual person who received that donation? Wouldn't that be nice? And that's a promise. That's something that technology blockchain offers to solve in the future if the platform becomes available. Okay, so to further give you some more relevance of blockchain in the current situation. In fact, CDC last May 27 discussed about 4 technologies that are meshing together to help to fight COVID-19. We know that, of course, AI is going to be there to help develop vaccines, big data so that we can model the viral outbreaks. Um, there's IoT that will help public health data collection. And for blockchain, along with those other technologies, blockchain will help make sure that there's a good supply chain manufacturing for vaccines, as well as help the insurance industry. And of course, they help out in the distribution of the medical supplies across the regions who need it. So all of these technologies come together to help fight COVID-19, and blockchain is one of those technologies. So that's the relevance, and hopefully by the end of this session, you'll have a greater appreciation of blockchain. And my personal intention is that coming out of this session, you will have a "Hey Ma" moment, wherein you will tell your mother, "Hey Ma, care to know about blockchain? So I just learned something from Accenture today, and I'm here to tell you about what blockchain is and what blockchain is not." So those are the high-level description of blockchain. But in the next 25 minutes or so, my colleagues and I will tell you more about blockchain. So in this 101 overview, we will discuss what is blockchain, the technologies behind blockchain, the industry applications of blockchain, and most importantly, the industry use cases. If you must know, the use cases of blockchain, there's a lot, but 90+% of blockchain use cases and projects have failed. And that's because they failed to connect the blockchain use cases and the technology. So that's very important to understand the use cases. Over the next couple of minutes, I will be joined by 2 of my esteemed colleagues as well. So I will be joined by Leo, who is the blockchain lead, and Risha, who is one of my blockchain technical architects in Accenture. But before I hand it over to Leo, I want to give you, let's say, 3 pieces of what blockchain is all about. So what the blockchain platform is all about. So while you're listening to this one-on-one session, think about these 3 things. Blockchain platform is all about trust. So it's about technology, enabling technology for a trusted data. So later on, we'll talk about hashing, cryptography, digital signatures, etc. So it's a system or a platform for trust. Aside from trust, it's a platform for multi-party systems. So again, we discussed about the use cases. So the first question is always about, why do we use blockchain? why can't I just use my own database or a SQL server or Amazon server or a database versus blockchain? So we will answer that later on with a good information on why do we use blockchain, what's a good use case of blockchain, and what is not. And lastly, so I mentioned about trust, multi-party system. The last thing that you have to remember is value. So what value it brings to the peers, the members, so that because there's going to be cost. So there has to be a good value for those members who are joining the system, as well as those who are using the system. So that's it. So hopefully you'll remember those while we continue the discussions. But before that, no, I think we should go ahead and move on to the next session. Leo, would you like to take over and discuss blockchain more in detail? Thank you.
Yeah, thank you, Nep. That is a very good introduction coming from you. So, like what Nep mentioned, I will be discussing some of the background related to the business needs for blockchain. So, my name is Leo Maningas. I'm the Blockchain Capability Lead Senior Manager for Accenture Philippines. Can we go to the next slide, please? Thank you. So I will be discussing why is blockchain important to business. So most of you are actually asking right now. Of course, there's a new technology right now, which is we call blockchain. And why is blockchain important to business side? So I will be discussing some details in terms of like what are the current problem scenario that we have right now for our business. So can we move to the next slide, please? Okay, so imagine this. This is like when you put your eyes about this specific picture that you are seeing here, we estimate greater than 30% of our business cost is based on lockup in data messaging and quality issues. And if you will be seeing here also in terms of how do we currently do a data exchange for each of the environment, it's very overwhelming for anyone that can be that can see this diagram. So if you will notice, there are like different environment, different areas where we can actually like transfer the data, validate the data, exchange the data, and do some handshake in terms of how the current business setup model is happening right now. So this is one of like the best idea in terms of what Neff mentioned in the introduction on how each of the business can actually like put a trust in terms of the process that they want to do, and how can we actually iron out each of this process so that we can have like a trusted environment where we can actually exchange our data from time to time. So can we move to the next slide, please? Okay, so what are the common challenges that we have right now for a traditional data system? So if you will be seeing in terms of like the common challenges that we have right now in the business, we are like encountering like redundancy in terms of many copies of data maintained by different participants, where the reconciliation process is really like a problem right now in the business that we are working with. Copy and paste, well, we don't know where the data came from, and this is like very relevant right now in terms of like how do you really get my data, or what type of data is that one, and who actually changed that data when you actually receive those type of data. Those are like the usual questions or challenges that we have in terms of the traditional data system. Of course, there are also like control problem where we have like blunt control mechanism in terms of like database, the table, and the row access control, where someone is actually like having problem in terms of like what are really like the different mechanism or the database and the table controls that we are actually implementing. And of course, the very important in any business type is the security. The security basically in terms of like the regular breach of any security model, we are actually experiencing it in terms of any like challenges with the traditional data system that we are experiencing right now. Okay, so to continue with the discussion with this one, let's move to the next slide. I will deep dive a little in terms of like the item that we have. So next slide, please. Okay. So this is like a model on how do you see right now the today's world messaging based on the business model that I actually discussed. So if you will be seeing there are actually like some messaging that is happening reconciliation within the traditional data system. And if you are actually seeing all the flow that we are seeing here, there are like different like system that are actually integrating with each others, trying to send the message and trying to provide different type of reconciliation, which is right now a major concern in terms of the traditional data system business model that we have. So we usually have this like interaction like, can you send me what I need? Here is what I know. So what do you know? Did you receive it or is it right? So this is like the type of validation that you are trying to like resolve within the traditional data system, because again, the trust is actually not there. And we're trying, of course, to verify those type of data that before I even like receive that and understand that, I need to get a proof on understanding, did I actually get it right? Did I actually receive it? Okay. So these are like some of the traditional business-based model concern that we are having right now on today's world. So can we move to the next slide, please? Okay. So tomorrow's new option, like what NEP discussed on this earlier discussion, is that this is like a blockchain-based business model that we have. So if you are seeing it right now, coming from a very chaotic messaging and reconciliation that today's business is actually encountering, in the blockchain promise, it's very simple. So like what Nep mentioned, as a takeaway for this learning, we can say that when someone asks blockchain, you can say that, blockchain. I see what you see what are the items that I want to share with you. So these are like the items that we really want to discuss with you and understand as we move forward. And for that discussion, my colleague, which is our capability lead from blockchain, our tech arc lead, Risha will be continuing the discussion in terms of the deep dive with the basic blockchain discussion. Risha?
Thank you, Leo. Hi, everyone. I'm Mary Shalom Maximo. Friends call me Risha, and I'm the technology architect for the blockchain capability in Accenture. And now I'm going to discuss the meat of this session, which is what is blockchain. For most of you guys, me included, my first impression of the blockchain is always Bitcoin. Bitcoin is the what we say is synonymous or interchangeable with blockchain, and there are also other cryptocurrencies like Ethereum, Litecoin, Ripple, whatever have you. But tonight, we're going to discuss it. We're going to shift your perception on Bitcoin, wherein blockchain is not equal to Bitcoin. It ca- uh, it did actually originate from Bitcoin, but as the blockchain technology evolved more and more, it has matured into its own technology. Wherein here in Accenture, we always say that blockchain right now is governed by the three basic technology components. It is basically a distributed ledger that is protected by cryptography and is governed by a consensus mechanism. So before we go deep further, we look into the Gartner hype cycle of blockchain. Uh, as you can see, blockchain is right here in the trough of disillusionment, but the picture is still as of August 2017. And in my opinion, I think we're already almost through with the trough of disillusionment, and we're already rising to the slope of enlightenment. And as you would see further on the different use cases, it really goes beyond the cryptocurrency. It goes beyond Bitcoin. So how does it work? On your leftmost side is the list of all your transactions, and then it will be represented as a block. A block can contain one or many transactions depending on the implementation of your blockchain. And then blocks are created by network participants and are attached to previous blocks. This new block will have an information of its previous block. Sometimes participants may disagree on the state of the ledger and propose two versions with conflicting transactions. But then again, as you proceed with other blocks, the conflict will be resolved depending on the consensus mechanism, and another block is formed and then it will merge into a single version of the ledger. So, like I said, it's a blockchain is a distributed ledger that is protected by cryptography. And for cryptography, sorry, it is mainly uh, Oh, it's actually composed of the three subparts, which is hashing, or the method to verify that the message has not been tampered with. Then there's encryption, a method to make the contents of the message unintelligible, and a digital signature. It's just to verify that the message actually came from the intended sender. Then we have different consensus mechanisms just to resolve all the conflicts that each participant would raise in the case of a blockchain network. First, we have proof of work. Proof of work is a consensus mechanism in Bitcoin. It utilizes a certain puzzle wherein the participants of the blockchain network would have to solve a certain puzzle, and whoever solves that puzzle will be the correct peer who would write into the Bitcoin network. Then there's proof of stake. In proof of stake, different other platforms actually use proof of stake, like Ethereum. It uses in the collection of stakeholders in the blockchain network, whoever has the most stake in that network will be the one who will dictate which of the transactions will go into the block. Then we have a practical Byzantine fault tolerance consensus mechanism, or the PBFT. This consensus mechanism is used by other blockchain platforms, rather, like for example Hyperledger Fabric. It has its own algorithm wherein it could resolve all the conflicting transactions that they would want to write in a single block. Then there's a zero knowledge proof. The zero knowledge proof is a popular consensus mechanism for identity blockchains, like for example, Hyperledger Indy. It is based on an approach wherein you have to prove something without having to reveal your actual information. Like for example, if I'm going to a bar and would like some liquor to drink, I will just have to present the proof that I'm over 18 rather than presenting an ID that has my actual birth date on it. And then last but not the least, we have the proof of elapsed time, or the POET, wherein if there is a transaction coming in, we'll just have to wait for a prescribed time before that transaction will be recorded in the block. Then we're proceeding to the other definitions that we usually do when it comes to implementing a blockchain application. First, we have a permissionless or versus a permissioned blockchain network. In permissionless, we mean that all users are anonymous and it's open to everybody. Each user has a copy of the ledger and participates in confirming transactions individually. Then we have a permission network. In this network, users are not anonymous. We definitely know who are the participants of that network. And then the permission is required for users to have a copy of the ledger and participate in confirming transactions. There is usually a governing body, usually the consortium or the governing body, that will dictate which of the users have a read-write access or which users have a read access only to the distributed ledger. And then going through our definitions further, we have a public distributed ledger, meaning that if we have a public distributed ledger, everybody is welcome to join in, whether on a read-only or a read-write permission access. So it's secured by crypto economics, the combination of economic incentives and cryptographic verification using mechanisms such as proof of work or proof of stake. Then we have a consortium distributed ledger, which is usually they usually implement a permissioned distributed ledger for this. We have a consensus process and it's controlled by a pre-selected set of nodes. And this set of nodes are usually corresponds to a particular user who is part of the consortium. The right to read the distributed ledger may be public or restricted to the participants. And we say that it's partially decentralized because the governing body here is a group of people who is working towards a certain incentive. And then lastly, we have a fully private distributed ledger. In here, the write permissions are kept centralized to one organization. Read permissions may be public or restricted to an arbitrary extent. But usually, this is just fully private, meaning we really need a certain permission just to join in. Rarely do we see this kind of blockchain networks to be open to the public. Likely applications include database management, audition, etc., internal to a single company. And so public readability may not be necessary, or in many cases not at all. Though in other cases, public auditability is desired. We have two models of blockchain solutions right here. First, we have the mutualized data. This is the model that Leo and Nep was talking about. All the participants of the blockchain network would want to um, maybe refer to a single source of data, which is your source of truth, so that each and every participant of that network would refer to that single source of truth and then do all the other application processes based from that data. And then we have a tokenized value transfer wherein wherein a certain party would exchange a certain type of goods or certain type of asset and then exchange it to a token. And then this token will be issued and then transferred from one entity to another. This tokenized value transfer is usually a model for the cryptocurrencies, but we can also use a token, value token transfer beyond cryptocurrency in a sense that we just exchange those tokens as a representation of the asset, and then there is really no money involved. As you could see here, for mutualized data, it's usually adopted by use cases that is related to identity. And then cross-border payments usually are aligned to the tokenized value transfer model. But if for other use cases like loyalty points and the bank or the supply chain, they could either adopt the mutualized data or the tokenized value transfer model for whatever their use case. So we have here, because of blockchain, we are moving from a traditional ecosystem wherein all of your data infrastructure always rely on one single source of data, one single source of database, or other sets of database, but it's still just one entity. We are now shifting to a blockchain ecosystem wherein all of all of the participants, all of the users refer to one single source of database, which is replicated to have their own copies for easier access. So now that we're going to the different use cases, what are the usually red flags or indicators that we usually look into just to say that you guys are would actually mostly benefit for a blockchain solution? Most of the blockchain solutions that we offer usually it's usually offered to clients that is number one that has multiple parties in the ecosystem. Like for example, in the use case of loyalty programs, we usually have one party that issuing the loyalty points, and you have other establishments that would rely on the number of the loyalty points and then prescribe their corresponding reward to give to the user. Then usually clients have a collaboration between known and unknown parties, whether it is in on their own subsidiary or in their own company network or even a competitor. Other use cases involve data or transaction validation maintained by multiple parties. Because there is an inherent distrust between those parties, that's why we usually prescribe blockchain as a solution for them. And of course, one of the key value proposition of blockchain is to remove the reliance on intermediaries. If we remove the intermediaries, we just go to the supplier and then the user. They would really just know that the assets that their or asset or data or whatever have you that they're exchanging are really valuable to both parties. And lastly, a nice use case that um, actually not really nice, but more of often often overlooked use case for blockchain is usually the need for a verified record or audit trail for all the parties involved in the network. So Where is the potential use case for blockchain? There's a ton of use case, but usually we usually offer them for different value. Usually offer them to these types of use cases, like for example, the digital identities. If you want to streamline your KYC or your know your customer process, then there's carbon credits to track what how much carbon you have already used or still need to use. Then we have the supply chain management, just to keep track of all the resources that you need to assemble one product that you're going to sell. Then there's also stock trading and real-time payments. We also use it for the document certification just to know the audit trail. Then we have decentralized infrastructures, copyright law just to make sure that your IP is really the IP that you're claiming for, points and rewards, as I have mentioned earlier, insurance claims, because you can subscribe to one insurance and then another entity will actually fulfill it for you. And then there's P2P, peer-to-peer lending and energy grid. There are actually a lot more use cases. You may actually have a use case already in mind. Feel free to chat it on the question and answer portion, and we can actually discuss it even for just a while. So that's it for the use cases. And here in that slide, I believe Nep would like to share something more about this.
Thank you, Risha. I think that's a very good overview. And again, this is just an overview session for blockchain. As mentioned a while ago, blockchain is a platform for trust. As what Risha mentioned, it's a platform for multi-party. So you have to think about, when we think about blockchain, you have to think about the parties that you will invite to share your data. So it doesn't make sense for you to put up a blockchain and you're the only one seeing the data. So that's why some monolithic companies, or at least if you're not sharing your data with somebody else, just use your own database. So that's one of the use cases that you have to think about, whether you're sharing data or you're not sharing data. So multi-party system is very important to consider about blockchain use cases. The last one is of course values. As what you've seen, it's not a matter of technology. So technology is going to be there. It's like AR, VR, AI. If the technology doesn't present value, then it's just a technology showcase. It's the same as blockchain. You have to think about, will the is there value in sharing data across my peers? So from what we've seen from the use cases that have become successful, it's about these technology companies, or let's say industry companies, coming together, sitting on a big round table and discussing what data they will share and how can this data, by sharing them, will help their industry as well as their customers. So again, those 3 points, I think Risha covered them in terms of security, value, and multi-party system. The slide that you're seeing is just a showcase, a quick showcase on Accenture being, of course, a technology company. We were not aligned to a specific technology. So we've been there 3, 4 years, 5 years ago, looking at the different technologies and partnering with the best of breed in terms of blockchain implementation, whether that's a secured, permissioned, semi-permissionless, as long as it's industry relevant. We've actually been partnering with a lot of startups, the academy consortiums, and also tech providers in making sure that we are building scalable solutions. Because for blockchain, as some of the questions I've seen, I mean, there's cost, there's servers, there's memory. It's not cheap to set up a blockchain environment. Just to give you a rough background, probably in Amazon, if you put up your own blockchain server, it's $1,000 easy, because it's mining, it's waiting, it's providing those compute power every second, every minute. So it's not cheap. So that's why the value has to be overwhelming enough to override the cost, the potential cost for blockchain. It's a lot of information to be dumped onto you for the last 30 minutes or so. So again, read about blockchain. We're sharing a YouTube video that will actually give you a simple appreciation on a very simple blockchain use case that you thought would not be possible. Next is, of course, thank you for attending the session. Hopefully, we'll see you on a daily basis. There's a ton of sessions that Accenture has provided. Of course, if you're doing something or doing nothing during this time, I think it's a good investment for 30 to 45 minutes to join in the sessions just to have a good understanding. And lastly, I again thank you everyone and thank you Accenture for organizing this. It's a different type of situation we're in, and hopefully through the use of technologies, we're able to serve our community a lot better. And you yourselves, as technology practitioners, continue to use these technologies not just to be rich, but also to think of use cases that will help our community, because I think that's what we need right now. Our innovators are thinkers, helping out each other to come up with a good value proposition to help our community.